There are more than 1 million wild alligators in Florida. That's the number everyone knows, and it's the one that scares people. Here's the part that should scare them more. The alligator might not even crack the top 3. In that same water, there are sharks that swim miles up freshwater rivers, pythons big enough to swallow one of those alligators whole, and an African crocodile, confirmed by DNA, that was never supposed to be on this continent at all. Florida is where the native monsters and the escaped ones ended up sharing the same swamp. Some of these animals have been here for millions of years. Some have been here about 20. None of them care which one you assume you're looking at. This is the list of the ones that can actually kill you. Before we start, wherever you are right now, whatever time it is on your end, put it down in the comments. American alligator. During a hard Florida freeze, the kind that hits maybe once or twice a decade, some alligators do something that looks like a magic trick. As the surface of a pond starts to ice over, the animal pushes its snout up through the water and holds it there, nostrils just breaking the surface. Then it stops moving. The ice closes in around it and locks it in place, snout sticking out of a frozen pond like a snorkel, and it just waits. Its heart, which normally beats around 30 times a minute, slows down to 2 or 3. Its body temperature drops to match the water. To anything walking past, it's a dead log frozen into a lake. It is not dead. It's in a state called brumation, running on almost nothing. And the moment the ice melts and the sun comes back, it thaws out and goes back to being one of the most efficient predators in North America, like nothing happened. That's the American alligator, Alligator mississippiensis, and it's the right place to start, because it's the animal Florida is built around. There are an estimated 1 1/3 million wild alligators in the state. They live in essentially every body of fresh water there is: lakes, rivers, swamps, drainage canals, retention ponds behind shopping centers, water hazards on golf courses. If it holds fresh water and it's warm, assume there's a gator in it. People in Florida have pulled them out of swimming pools and found them sitting in garages. This is not a rare animal you travel to see. It's the local wildlife, and it is built like something that was designed to win. The bite force of a large adult alligator has been measured at around 2,125 pounds per square inch. To put that in something you can feel, or a strong human bite is around 150 to 200 psi. The alligator is doing more than 10 times that. It's enough force to snap large bones instantly and crush a turtle's shell like a cracker, which it does regularly. Because turtles are on the menu and that armored shell is not the problem it looks like. So here's where it gets strange. All that crushing power is in the muscles that close the jaw. The muscles that open the jaw are almost pathetically weak. So weak that a grown person can hold an alligator's mouth shut with one hand. So weak that the people who handle them professionally keep the jaws closed with a single wrap of ordinary electrical tape. Think about that. An animal that can bite through bone can be disarmed with the kind of tape you'd use to bundle a charging cable. The catch, obviously, is that none of that helps you once the mouth is already open and moving, and it moves faster than it has any right to. Part of how it moves is that it can see you in total darkness without using its eyes at all. Look closely at the skin around an alligator's mouth and jaws and you'll see thousands of tiny black dots. Those are integumentary sensory organs, pressure sensors, and they are absurdly sensitive. They can pick up the faintest ripple or vibration in the water from meters away. A fish twitching, a bird landing, a hand breaking the surface. In black, muddy swamp water where seeing nothing is normal, the alligator doesn't need to see. It feels the water move and it knows exactly where the movement came from. And it closes the distance before the thing that made the ripple understands it's being hunted. And then there's the part that genuinely rewrote what scientists were willing to say about this animal out loud. Alligators use tools. During the nesting season for wading birds, herons, egrets, the birds need sticks to build their nests, and good sticks get scarce. Researchers in Florida and Louisiana documented alligators balancing sticks and twigs across their snouts and lying dead still just under the surface near the nesting colonies. A bird drops down to grab the free building material. The free building material eats it. This isn't a one-off accident. It lines up with the exact weeks the birds are nest building, which means the alligator is, in some functional sense, baiting a trap and timing it to the calendar. It's a reptile that figured out how to go fishing for birds with bait on purpose. Bull shark, from the thing that owns Florida's fresh water by force to the thing that snuck into it. Most people picture sharks the way the movies taught them: open ocean, deep water, far from shore. Which is exactly why the bull shark is so dangerous. Because there's a canal system running behind a lot of the waterfront homes in places like Miami and Fort Lauderdale. Calm, green residential water with a manicured lawn on each side and a boat tied up at the dock. And acoustic tracking studies have found that young bull sharks use those canals as a nursery. The big ocean predators can't get in there, so it's safe for the pups, which means the families living in those houses, swimming off their own docks, are doing it directly above a nursery for one of the most aggressive sharks on Earth. This is the bull shark, Carcharhinus lucus. And the thing that makes it different from every other big shark is that it doesn't respect the line between salt water and fresh. Almost every other shark dies in fresh water. Their bodies are tuned for the salinity of the sea, and in fresh water their cells flood and rupture. The bull shark's kidneys and a special gland near the tail let it constantly retune its own internal chemistry to match whatever water it's swimming in. So it can leave the ocean and swim straight up a river and keep going. Bull sharks have been recorded over 1,000 miles up the Amazon. One was famously found in the Mississippi River as far north as Illinois. In Florida, they swim up rivers, into lakes, through the canals, into water you would never ever look at and think shark. So sit with the picture. A calm freshwater river in the Florida interior, miles from any beach. The kind of place where someone takes a swim to cool off. And an 8-foot bull shark is in it because nothing about that river told it to stop. That's the paradox of this animal. The danger isn't out past the waves. It followed the water inland, and it's a bad animal to run into anywhere because it runs hot. Bull sharks carry some of the highest testosterone levels measured in any animal, which tracks with how territorial and quick to react they are. Their bite has been measured at around 1/300 psi at the back of the jaw, which, pound for pound, makes it proportionally the hardest biting shark there is, outbiting the great white in that specific measure. Combine the aggression, the bite, the willingness to be in shallow, murky water near people, and the fact that they're often the shark involved when something happens close to shore, and a lot of researchers consider the bull shark the most dangerous shark to humans. Full stop. Not the most famous one, the most dangerous one. The famous one at least has the decency to stay in the ocean. Alligator snapping turtle. The one we're going to now does the opposite of all that. It doesn't swim up to find you. It's been lying at the bottom the whole time, holding completely still with its mouth open, at the bottom of a deep, slow river in the Florida Panhandle. There's something that looks like a rock covered in moss, with its mouth hanging open. Inside that open mouth, on the floor of its tongue, is a small pink worm-shaped piece of flesh, and it's wriggling. It twitches and curls exactly the way a live worm does. A fish sees an easy meal sitting inside a dark cave, swims in to take it, and the cave closes. That's the alligator snapping turtle, Macrochelys teminki, and the worm is part of its tongue. It evolved a living lure, so it never has to chase anything. It just has to be patient, and it has nothing but time. This is the biggest freshwater turtle in North America, and it looks like it wandered in from the age of dinosaurs, which is more or less accurate. 3 rows of jagged ridges run down its shell like a mountain range. The skin hangs in rough spikes, and the head ends in a hooked beak. Big ones top 100 kilograms, over 200 pounds, and they can live the better part of a century, sitting in the same stretch of river for decades. It looks slow. On land it is slow, heavy, lumbering, awkward, the kind of thing you'd assume you could easily step around. That assumption is the danger, Because the lumbering, awkward animal can extend that thick neck and snap forward at a speed people compare to a striking snake. From dead still to bite is almost too fast to register. And the beak it's snapping with is built like a guillotine, a hooked blade of keratin driven by a huge slab of jaw muscle, with a bite measured near 1,000 psi. That's force engineered to crush bone and shear through submerged branches without the beak so much as chipping. It is more than enough to take a human finger off cleanly, not break it, remove it, which is the actual, ordinary danger here, not some dramatic death, but a swimmer or a wader reaching down into murky water near the bottom and finding out instantly that the rock was not a rock, and these animals are almost unreasonably tough. When researchers in Florida x-rayed old wild snapping turtles, they kept finding the same thing: fishing hooks. Old steel hooks, swallowed years or even decades earlier, lodged deep in the stomach and the surrounding tissue, some of them rusting in place. And the turtles were fine. No infection, no sign of decline, just an old animal walking around with a tackle box slowly accumulating inside it, completely unbothered. Some of them have been carrying that hardware longer than the person who lost the hook has owned the boat. Eastern diamondback rattlesnake. Everybody knows the sound. The dry, papery buzz coming out of the grass that tells you to stop walking immediately. What almost nobody knows is what's actually making it, because the mechanics of that sound are one of the strangest things in the animal world. The rattle on the end of an eastern diamondback's tail is shaken by a set of muscles that can contract and relax up to 50 times a second, and they can hold that rate without stopping for hours. There is no other muscle tissue in any land vertebrate that can do that. Run any other animal's muscles at that speed and they'd overheat, cramp, and die within minutes. The snake just keeps going like an idle engine, for as long as it takes for the threat to leave. This is the eastern diamondback rattlesnake, Crotalus adamantius, the largest venomous snake in North America. And it lives in exactly the parts of Florida people walk through without thinking. The pine flatwoods, the palmetto scrub, the dry rural edges of the suburbs, often tucked into the mouth of a gopher tortoise burrow. A big one can pass 2 meters and weigh as much as a small dog, and you will not see it, because the diamond pattern down its back dissolves into a floor of pine needles and dead leaves like it was painted to match. Here's the part that flips everything. This animal, one of the most lethally equipped snakes on the planet, is a coward, and that rattle is the proof. The buzzing is not a threat, it's a plea. The snake does not want to bite anything it can't eat, because venom is metabolically expensive to produce and a human leg is not food. So it would much rather burn energy shaking its tail and begging for distance than spend a single drop of venom on something it'll have to walk away from anyway. The rattle is the snake saying, as loudly as it can, "Please don't make me do this." And what it's trying not to do is genuinely horrifying. Between its eyes and nostrils are 2 small pits, heat sensors so fine they can register a temperature difference of a few thousandths of a degree. The snake's brain takes that information and builds a thermal image, an actual infrared picture of the warm shapes around it. In total darkness, it can see the glowing heat signature of a mouse or a foot with enough resolution to aim. It's hunting with night vision built into its face. When it does decide to spend the venom, the numbers stop being abstract. A single bite from a large diamondback can inject 400 to 450 milligrams of venom, and in the biggest snakes, more than 800. The amount it takes to kill an adult human is somewhere around 10 to 15. So one snake is walking around with enough venom for dozens of people all the time. And the venom itself works fast and works ugly. It carries a compound that attacks the blood's ability to clot and goes after the walls of the blood vessels directly. In a bite victim, blood starts leaking out of the vessels and into the surrounding tissue. The body comes apart from the inside before the heart ever gives out. The diamondback at least warns you first. The next one doesn't believe in warnings. Eastern coral snake. The next one says nothing at all. No rattle. No hiss, no flared hood, no fake lunges, no theater. The eastern coral snake doesn't do any of the things other dangerous snakes do to be noticed. because it isn't trying to be noticed. If left alone, it stays still or quietly slips away. The only way most people meet one is by stepping on it or reaching down near it. And then it bites, instantly, with a fast sideways snap, and goes back to minding its business while the person who got bitten often feels almost nothing. This is the eastern coral snake, Macrurus fulvius. And behind those bright red, yellow, and black bands is the most potent neurotoxic venom of any snake in North America. There's an old rhyme people in the South learn as kids. Red touch yellow, kill a fellow. Red touch black, friend of Jack. And it exists because a harmless snake. The scarlet king snake copies the coral snake's colors almost exactly, and the band order is the only quick way to tell the lethal one from the imposter. The rhyme is a memory trick for a snake that gives you no other clues. Now, the coral snake has a hardware problem that should make it less dangerous, and somehow makes it stranger instead. Unlike a rattlesnake, it doesn't have long, hinged fangs that swing out and stab. Its fangs are short and fixed at the front of the mouth. It physically cannot deliver a fast, deep slashing strike, so instead it has to bite down and hold on, working its jaws, chewing almost, to feed the venom into the wound through grooves in those little fixed fangs. It's a slower, clumsier delivery. The reason it doesn't matter is what the venom does once it's in. It goes after the connection between the brain and the muscles. The venom blocks the chemical signal at the exact junction where nerves tell muscles to move, and it does it without causing much pain or swelling at the bite. So there's no dramatic local wound, no screaming agony. There's a small bite that barely hurts, and then a delay. Hours can pass, and while the person feels like they got away with it, the venom is quietly switching off the muscles, including the ones that run breathing. The diaphragm stops taking orders. The danger isn't poison spreading through the body in a burning wave. It's a slow, painless disconnection that ends with the lungs simply refusing to work. Before the specific antivenom existed, the historical death rate from coral snake bites ran somewhere around 20 to 25%, and the cause of death was almost always the same. The person stopped being able to breathe. And here's the quiet, modern problem layered on top of all of that. Coral snake bites are rare, and the snake is difficult to milk for venom. So at one point, the only company making the specific antivenom in the United States simply stopped. It wasn't worth producing. The existing stockpile aged, and the official expiration dates came and went. And Florida hospitals were left holding vials of the only thing that reliably treats this bite, past their stamped expiration, with the FDA repeatedly extending the dates so the expired medicine could still be used in an emergency. A bite from one of the most neurologically lethal snakes on the continent, treated with antivenom that's technically out of date because nobody could justify making more. Florida bark scorpion. Now down a size, into the part of the danger that comes indoors. Turn off the lights, switch on a UV flashlight, and a scorpion will betray itself instantly. Its whole body lights up a glowing, electric blue-green, like something out of a vending machine. The Florida bark scorpion, Centroides gracilis, does this, and it's not a trick of the light or a coating. The shell itself is fluorescent. Proteins built into the cuticle soak up ultraviolet light and throw it back as that eerie glow. Nobody is completely sure why. One leading idea is that the entire exoskeleton works as a single, body-sized light sensor, the scorpion using the glow to gauge how much light is hitting it, so it can find the darkest crack available and disappear into it before dawn. An animal that detects light with its whole skin in order to hide from it better. This is the largest scorpion in Florida, and the darkest crack available is frequently a problem, because the cracks it likes are under tree bark, under wood piles, under loose siding, and the gap under a door, and the inside of a boot left on the porch overnight. It is built to survive almost anything. It can ride out a brief freeze, and it can go for months with no food and not a single drop of water by dropping its metabolism down to almost nothing, basically idling until conditions improve. The good news, such as it is that for a healthy adult the venom is rarely deadly. The bad news is that rarely deadly and harmless are very different things. The sting delivers a sharp, electric, neuropathic pain. Survivors describe it like a prolonged jolt of current, rather than a normal puncture, and it does that through peptides in the venom that jam the channels in your nerve cells that regulate pain signals. So the nerve keeps firing the pain message with nothing to shut it off. It burns for hours, and there's frequently no wound to show for it, no real swelling, no torn tissue, nothing. Just a small mark and a part of the body that feels like it's being held to a stove. And if the scorpion gets pressed against skin, say by a foot sliding into that boot, it doesn't sting once. The tail can land several stings in under a second. Florida giant centipede, which is unpleasant. But it's not the worst thing in this category that can be waiting in a damp corner of a Florida house. That title goes to something with a lot more legs and a much worse attitude. There's a predator in the wet corners of South Florida, the damp basements, the mulch beds, the gap behind the garden hose, that attacks things it has no business attacking. The Florida giant centipede, Scolopendra viridis, will grab and try to subdue almost anything it can physically hold down. Insects, sure, but also mice, lizards, and small snakes, prey several times its own size, pinning them and driving venom straight into their nervous system. For its weight, it's one of the most aggressive hunters around, and it does not seem to do risk assessment. And the weapon it's hunting with is the part that doesn't make sense the first time you hear it. The two curved fangs hooking out from under its head, the things it jabs venom with. Those are not jaws. They're not teeth. They are its first pair of legs. Over millions of years, the front legs evolved into a set of hollow, pointed, venom-injecting hooks called forcipules that work like fangs but answer to the anatomy of a leg. The centipede isn't biting you with its mouth. It's stabbing you with a modified pair of its own feet. What comes through those modified feet is a chemical mix built for maximum misery. It ruptures red blood cells, and it carries a component that interferes with the flow of potassium in heart muscle cells, which is what drives the violent muscle spasms and the spreading, full-body pain people report from a serious bite. And the pain has staying power that doesn't match the size of the animal. Lab work has pulled a specific toxin out of this group of centipedes that acts on the sodium channels and mammal nerve endings and basically simulates a continuous chemical burn, which is the scientific reason a centipede bite can keep burning for days and shrug off ordinary painkillers like they were never taken. Trying to deal with one by hand is its own kind of mistake because that long, segmented body can reverse a full 180 degrees in a fraction of a second. Reach for the head and the tail end is already coming around. It is, for all practical purposes, impossible to grab cleanly, which means almost everyone who tries ends up demonstrating firsthand exactly what those repurposed front legs are for. Burmese python. Here is the most unsettling fact about the biggest snake in the Everglades. You could be standing 10 feet from one and never know. Scientists have run the numbers on this, and in the areas where Burmese pythons are thickest, the odds of a human actually spotting one in the vegetation are estimated at well under 1%. Not because there aren't many, when there are tens of thousands, but because a snake that can grow longer than a car becomes, in that landscape, completely invisible. It lies still under the sawgrass, its pattern breaking up against the light and shadow, and people walk past it. Airboats pass over it. Search teams trained specifically to find it walk right by. It's the strangest thing about the whole invasion. The single most ecologically destructive animal in South Florida is also the one almost nobody ever sees. This is the Burmese python, Python bivitatus, and it isn't supposed to be on this continent. It came through the exotic pet trade. Snakes bought small and cute that grew into something nobody could house and got dumped into the swamp. One theory points to a breeding facility wrecked by Hurricane Andrew in 1992, releasing animals all at once. Mostly it was a slow drip of released pets that found each other, and, in the warm water and endless prey of the Everglades, did exactly what they were built to do. By around the year 2000, they were established. Now they're a permanent part of the ecosystem, and the ecosystem is paying for it. A USGS study laid the damage out in numbers that are hard to absorb. In the areas where pythons took hold, the populations of raccoons, opossums, and bobcats dropped by 90 to 99%. Marsh rabbits effectively vanished. These weren't animals dying of disease or losing their habitat. They were being eaten methodically until the mammals that had defined those wetlands for thousands of years were simply gone. A silent, total collapse of the food web, carried out by an animal most people in the area have never laid eyes on, and the machinery that does it is genuinely science fiction. When a python swallows something large, and large can mean a full-grown deer or an alligator, its body has to handle a metabolic load that would kill almost anything else. So it rebuilds itself on the fly. Within about 48 hours of a big meal, the snake's heart, liver, and kidneys can swell in size by anywhere from 40 to 100%, growing new tissue specifically to process the meal, then shrinking back down to normal once digestion is finished. The organs inflate and deflate around each meal like the animal is renovating its own insides every time it eats. Even the swallowing is a misunderstood feat. The popular idea is that a snake unhinges or dislocates its jaw, and that's not what happens. The two halves of the python's lower jaw aren't fused together at the front. They're joined by a stretchy ligament so they can spread apart independently. The skin and the muscles of the neck stretch to a degree that seems impossible. The snake doesn't break anything. It expands its entire front end around the prey, walking its jaws over an animal up to twice the diameter of its own body, and then the stretched-out tube of muscle moves it down, and it knows the way home. In a tracking study, researchers picked up pythons and moved them tens of kilometers from where they were caught, then watched what they did. Nearly all of them turned and navigated back, in essentially straight lines, through a maze of identical-looking marsh, water, and saw grass with no obvious landmarks, and returned to within a short distance of their original capture site. A snake with no map in terrain designed to get a human hopelessly lost, has some internal sense of where it is and where it should be, and it doesn't get confused. Walking catfish, the python travels invisibly. The next invader announces itself by crossing the road. Drive through certain low parts of Florida on a warm, rainy night, and the road will appear to be moving. Dark shapes flexing across the asphalt, dozens of them, all heading the same direction, from one flooded ditch toward another. They're fish. Specifically, they're walking catfish. And they are doing exactly what it sounds like. Traveling across dry land, on a road, in the rain, to get to new water. This is the walking catfish, Clarius batrachus, another import that got loose, brought over from Southeast Asia through the fish trade in the 1960s and into Florida's canals, and it has a set of tricks that make it almost impossible to get rid of. The walking is real locomotion. It plants the stiff, sharp spines of its pectoral fins like a pair of crutches, props itself up, and whips its body side to side, dragging itself forward across solid ground. It can keep that up for hours, covering real distance overland to reach a new pond or drainage canal, which means it doesn't need rivers or connections to spread. It just gets out and walks to the next watershed. The reason it can survive the trip is an organ most fish don't have. Inside its gill chamber is a branching tree-like structure that works as an accessory lung. As long as it stays damp, the catfish can pull oxygen straight out of the open air and breathe it. And that same organ lets it live in water that would kill almost anything native, stagnant. Filthy, oxygen-starved ditches where a normal fish would suffocate in minutes are, to the walking catfish, perfectly good real estate. You cannot drain it out, you cannot starve it of clean water, and you cannot fence it in. It breathes air and it travels on foot. During droughts, this gets expensive. The catfish will walk at night straight into commercial fish farms, crawl up out of one pond, across the ground and down into the stock tanks, where they proceed to eat thousands of dollars of farmed fish before anyone notices. And during the day, in the cities, researchers have found them packed into the storm drains under the sidewalks. They use the urban drainage system, the pipes running beneath the streets, as a private network of tunnels, moving from one neighborhood to the next underground out of sight, colonizing new territory through the infrastructure built to carry away the rain. An invasive fish that figured out the sewer is faster than the surface. Red imported fire ant. The last invader in this part is the smallest, and the one that turned Florida's floods into a way to win. When the water rises, a tropical storm, a flooded yard, a canal jumping its banks, a fire ant colony does something that shouldn't be possible. Instead of drowning, the entire colony links together. Tens of thousands of ants grip each other with their claws and jaws, body to body, and weave themselves into a single floating raft, a living, waterproof structure with the queen and the eggs tucked safe and dry in the center. The raft floats. It can stay afloat for days, drifting across the floodwater until it bumps into dry land, or a tree, or the side of a house where the colony pours off and starts again, fully intact. This is the red imported fire ant, Solenopsis invicta, a South American species that came into the United States through the port of Mobile, Alabama. In the 1930s, riding in soil used as ship ballast, and spread across the southeast into Florida, where the climate suits it perfectly. The mound-shaped nests are everywhere: pastures, parks, ball fields, suburban lawns, and they react to disturbance with a coordination that's genuinely eerie. Step on a mound and you don't feel the first sting right away. The ants swarm up the leg in silence. They don't bite as they climb, they wait. And then a chemical signal passes through the group, a pheromone cue. And on that cue, hundreds of them sting at the same instant. The synchronized attack isn't an accident of timing. It's a broadcast. Each ant is tiny, its individual sting minor. The strategy is to be many, and to all fire at once. And the fire ant doesn't sting the way most ants sting. Most ants just spray formic acid. The fire ant has a real functioning stinger fed by glands that produce an oily alkaloid venom, a compound that destroys cells in the skin and raises the signature white pustule a day or two later. The little blister that itches, breaks, and gets infected easily. For most people, it's misery. For someone allergic or very young or very old, a mass stinging event is a medical emergency, and people do die from the reaction. The damage adds up in ways that go far past the bites. Fire ants are drawn to electrical fields, and they pack into transformers, junction boxes, and electrical equipment until they short it out, chewing through the state's infrastructure as a side effect of their own biology. Add up the medical costs, the agricultural losses, and the wrecked electrical equipment, and the estimated bill for fire ants in the United States runs somewhere north of $6 to $7 billion a year. And that floating raft? The thing that lets them shrug off Florida's floods turns out to be even stranger than it looks. When physicists studied it, they found the raft behaves like a non-Newtonian fluid, a material that's both liquid and solid depending on how you treat it. Press into it slowly with a stick, and it deforms and flows around the stick like honey, then reforms. Hit it and it pushes back like a solid. Through all of it, the ants don't let go and the raft doesn't sink, holding a pocket of air underneath so that the ants on the very bottom, fully submerged, can keep breathing for days. The colony isn't just surviving the flood. It's been engineered, by nothing but bodies holding onto each other, into a self-healing material that water can't beat. Blacktip shark. There's a stretch of coastline in Volusia County, around New Smyrna Beach, that has recorded more shark bites than anywhere else on the planet. It's earned the nickname, the shark bite capital of the world, and the numbers behind it are steady enough that researchers will say, Plainly, that if you've swum at that beach on a summer afternoon, you have almost certainly been within a few feet of a shark without knowing it. Not once, probably many times. The water is just that full of them. The shark doing most of it is the blacktip, Carcharhinus limpidus, a sleek 5 to 6 foot animal that hunts in the worst possible place to share with people, the surf zone, the band of breaking waves right where everyone stands. That water is churned up with suspended sand, so visibility down there is close to zero. The blacktip isn't hunting people. It's chasing small fish in the chaos of the breakers, and it's doing it almost blind, striking at flashes, a flicker of movement, a glint of silver, a quick pale shape. It commits to the strike before it can possibly confirm what it's biting, which is the entire reason its bites almost never kill. Nearly every blacktip bite on a human is a case of mistaken identity. A silver watch catching the light, the pale flash of a palm, or the sole of a foot kicking through murky water. To a shark built to strike at silver flashes, that reads as a fish. So it bites. And then, almost instantly, it realizes the mistake and lets go. It's called a hit and run, and it's why most blacktip bites are a single wound to a hand or a foot rather than anything worse. The shark wanted a mullet. It got a surfer's heel, didn't like it, and left. What lets it strike that fast in water it can't see through is a sixth sense built into its snout. Spread across the pointed nose are tiny gel-filled pores, the ampullae of Lorenzini, and they detect electricity. Every muscle contraction in a living animal, including the beating of a small fish's heart, throws off a faint electrical field, and the shark reads those fields like a map. So even when its eyes are useless, buried in churning foam and sand, it can sense the electrical signature of life nearby and aim at it. The strike isn't guesswork. It's locked onto something it can feel through the water, and there are a lot of them, all moving together. During the annual migrations up and down Florida's east coast, blacktips travel in enormous schools. And aerial footage has caught the truth of it. Thousands of sharks streaming along the shoreline, passing within 30 meters of swimmers who have absolutely no idea. The whole school sliding by just outside the breakers like a current with teeth. Satellite tracking has shown those migrations are timed to the water itself. The sharks follow the temperature shifts driven by the Gulf Stream, moving up and down the coast as a kind of slow wall, tracking the exact thermal band where the feeding is best, arriving at the beaches on a schedule written by the ocean. Box jellyfish. The blacktip bites because it can't see. The next animal sees in every direction at once, and it does it without a brain. It has 24 eyes and no brain, which is one of those sentences that sounds made up. The box jellyfish living off the Florida coast, a species of sea wasp, Chiropsalmus quadrimanus, carries 24 eyes, arranged in clusters around its bell. Most of them are simple light detectors, but 4 of them are startlingly complex, with lenses, retinas, and corneas built on the same basic plan as a human eye. And the animal has no central brain to send those images to. There's no command center, no head, nothing you'd point to and call a mind. Just a diffuse net of nerves spread through the body, somehow taking input from 24 eyes and turning it into coordinated behavior. Nobody fully understands how a brainless animal uses image-forming eyes to navigate. It just does, and it does navigate, which is the part that breaks the usual idea of what a jellyfish is. Most jellyfish are passive. They drift wherever the current takes them. This one swims. It can actively push against a current at speeds up to around 2 knots, and it uses those eyes to steer around obstacles, changing course to avoid things in its path. It isn't floating through the ocean waiting for food to bump into it. It's hunting on purpose, with direction. Its weapon is a kind of biological machinery so fast it barely fits in the category of animal. The tentacles are lined with millions of microscopic capsules called nematocysts, each one a tiny pressurized harpoon, a coiled, barbed thread under enormous internal pressure. When a trigger fires one, whether by touch or by a chemical cue from skin, that thread shoots out at a speed and acceleration that put it among the fastest movements in all of biology, driving the barb into flesh and injecting venom in a span of time measured in fractions of a millionth of a second. A single brush against a tentacle fires thousands of them at once. There's no warding it off, no pulling away fast enough. By the time the contact registers, the venom is already in, and the venom is built to hit several systems at the same time: the skin, the nervous system, and the heart, all at once. The pain is the immediate problem. Survivors describe it as so far beyond ordinary pain that the body can go into shock within about 3 minutes. And that's the real danger in the water. Not a slow poisoning, but pain severe enough to cause a person to lose function and go under before the venom ever reaches the heart. The thing that makes it lethal at sea is how fast it overwhelms someone who is, at that moment, trying to stay afloat. The worst part, for Florida specifically, is where it chooses to be. Researchers have found these box jellies moving into very shallow, calm water, the warm, gentle stretches right off public beaches, on summer high tides, following small crustaceans in to feed, which puts a nearly transparent, actively hunting, brainless animal carrying one of the fastest venom delivery systems on Earth into the exact patch of water where families wade in July. It's almost invisible. It's moving toward shore on purpose, and it arrives in tourist season: hardhead catfish. The last danger on the beach doesn't swim toward anyone. It's already on the sand, and it doesn't even need to be alive. People assume a fish is dangerous at the mouth, the teeth, the bite. The hardhead catfish breaks that assumption in the worst way, because the thing that gets you isn't its mouth, and the fish doesn't have to be alive to do it. The most common injury comes from stepping on one that's already dead, a hardhead caught and tossed onto the beach, or washed up and left in the sand, because its weapons stay armed for days after it dies. The hardhead catfish, Ariopsis felis, is everywhere in Florida's coastal waters and bays. The fish anglers pull up by accident and curse at, and it comes equipped with 3 venomous spines, one on the back, one on each side. When the catfish is grabbed or stressed, it throws those fins out sideways and locks them rigid through a special bony joint, turning its whole body into a stiff spiked cross that's almost impossible to handle or swallow. That locking mechanism doesn't relax when the fish dies. The spines stay rigid, upright, and fully capable of injecting venom long after the animal is gone, which is how a bare foot finds one in the sand. Each spine is sheathed in venom-producing tissue and lined with serrations that point backward, like the barbs on a fishhook. When the spine drives into flesh, the sheath tears open and releases a venom that kills the surrounding tissue and produces immediate, savage, inflammatory pain. And then the barbs become their own problem. Because the serrations face backward, you cannot simply pull the spine out the way it went in. Trying to drags those rear-facing barbs through muscle and tendon and blood vessels, shredding the wound wider on the way out. Doctors in Florida often can't pull these spines. They have to push the spine the rest of the way through the limb, out the other side, to cut the barbed tip off before they can remove it at all. And the wound it leaves opens a door to something worse. Analysis of the venom found that it carries potent compounds that clamp down the blood vessels at the injury site, choking off the local blood supply and starving the tissue of oxygen. That dead, oxygen-poor pocket of flesh turns out to be a near-perfect breeding ground for Vibrio vulnificus, a flesh-eating bacterium that thrives in exactly the kind of warm coastal water Florida is full of. So the spine doesn't just deliver venom and a ragged wound. It manufactures the precise conditions, deep in the tissue, that one of the most dangerous bacteria in the water has been waiting for. North American river otter. The river otter is the animal on the postcard. It's the one in the wildlife park that slides down mud banks and floats on its back and pulls a crowd. People love otters. And every so often in Florida, Someone wading in a recreational lake gets attacked by one and comes out of the water with 30, 40 deep puncture wounds. Because the gap between what this animal looks like and what it actually is may be the widest of anything on this list. The North American river otter, Lontra canadensis, is not a cute aquatic clown. It's a semi-aquatic predator from the weasel family, the same family as badgers and wolverines, which should tell you something. And it is intensely territorial. When one feels cornered or is guarding pups, it doesn't bluff and it doesn't leave. It commits, and in deeper water, it has every advantage, coming at a swimmer again and again from different angles, fast and low, until the person is exhausted and bleeding from a dozen places. They've documented dozens of these attacks in Florida in recent years. Underneath the playful reputation is basically a metabolic furnace that never stops needing fuel. To hold its body temperature in the water, the otter burns energy at an enormous rate, which means it has to eat something like a fifth to a quarter of its own body weight in meat every single day. There is no off switch on that. It's a small animal that is, by necessity, hunting and killing almost constantly, and the teeth it does it with are built for the job. Molars and premolars made to crush through hard fish bone and crab shell, with enough force to punch through a skull. The body that looks designed for cuteness is actually optimized end to end for eating other animals, all day, forever. And there's one more thing that turns the occasional otter from territorial to deranged. Researchers who looked at the worst otter attacks on humans in Florida kept finding the same factor: rabies. A large share of the otters involved in severe unprovoked attacks tested positive. Rabies switches off the animal's natural caution around people, strips out the fear that would normally keep it away. And what's left is a 14-kilogram predator with no hesitation. In the water, where it's most dangerous. The cute animal didn't change its nature. The virus just deleted the part that was holding it back. Southern black widow, stay with the underestimated, and shrink it down to something you could cover with a bottle cap, drop for drop. The venom of a black widow is often cited as around 15 times more potent than the venom of a diamondback rattlesnake. That's the number that gets repeated, and it's accurate as far as it goes. What saves people is the catch hiding inside it. The widow is tiny, and the amount it actually injects is minuscule compared to what a rattlesnake delivers. So the same venom that, gram for gram, dwarfs a rattlesnake's, arrives in a dose small enough that a healthy adult, treated properly, usually recovers. Tiny syringe, terrifying payload. The southern black widow, Latrodectus mactans, loves Florida. And it lives exactly where hands go without looking. The corner of a garage, the inside of a water meter box, the underside of a barbecue grill, the dark of a construction site porta potty. The female is the dangerous one and the famous one, marked with the red hourglass, and she has a domestic habit that fits the theme of this whole part. She frequently eats the male after mating. It isn't cruelty, it's accounting. She's about to produce hundreds of eggs that takes protein, and the male is right there. A free meal that improves the odds for the next generation. Her web tells you not to trust appearances either. It has none of the elegant geometric spokes and spirals beauty of a garden spider's web. It's a messy, chaotic, ugly snarl of threads with no pattern at all. But those ugly threads are made of silk with a tensile strength that, pound for pound, outperforms structural steel. And what the web catches, the venom finishes. Alpha-latrotoxin works by attacking the nerve endings directly, forcing them to dump their entire supply of neurotransmitters all at once, in an uncontrolled flood. The result is a condition called latrodectism, violent, full-body muscle cramping, a racing heart, and abdominal pain so severe it has been mistaken for a burst appendix on the operating table. No torn flesh, no dramatic wound. Just a tiny bite and a body that turns on itself. And she's currently in a fight you'd never notice, happening in garages across the state. An invasive cousin, the brown widow, is moving in and pushing the native southern black widow out. quietly winning the suburban territory, square foot by square foot, and shoving the black widows into the darkest, most confined corners of people's homes. A turf war between two venomous spiders fought entirely in the spaces humans don't look. Florida false wandering spider. The next spider isn't dangerous at all. It just does an extremely convincing impression of something that is. Corner one of these in the leaf litter, and it will rear up. Lift its front legs high and hold a pose that is almost a perfect copy of one of the most feared spiders on Earth. That posture, legs raised, fangs presented, is the signature threat display of the Brazilian wandering spider, an animal with genuinely dangerous venom. The Florida false wandering spider, Cutinus captiosus, does it flawlessly, and it's a bluff. The venom behind that terrifying display is medically minor for a healthy person. Nothing close to the cardiac threat its body language is advertising. The whole performance is evolutionary theater. Look exactly like the thing that can kill you, and predators leave you alone without your ever having to back it up. The bluff is about all that's gentle about it, though. This is a pure hunter that builds no web. It runs its prey down on the forest floor at night, native across Florida, hiding in leaf litter and debris by day, and chasing amphibians and small reptiles after dark with sudden bursts of speed. It hunts on hardware most people associate with geckos. The tips of its legs carry dense tufts of microscopic hairs, and those hairs generate enough molecular adhesion, van der Waals force, that the spider can run straight up smooth glass or across a ceiling, then drop directly onto whatever it's hunting, and it aims with a pair of oversized forward-facing eyes, unusually large and developed for a wandering spider, giving it real depth perception out to 15 or 20 centimeters in complete darkness. How far that hunting will go is the part that sticks. Researchers mapping the spiders of Central Florida found this species had moved into the state's limestone caves and worked out what it was eating there: juvenile bats. Young bats that lose their grip and fall from the cave ceiling get taken by the spiders waiting below. A spider whose entire reputation is built on a harmless bluff turns out, in the dark of a cave, to be eating small mammals out of the air. Florida black bear. From the smallest thing pretending to be dangerous, to the largest thing in the whole state pretending it isn't there. The black bears that live near Florida's cities have learned the garbage schedule. Studies of urban bears found they'd shifted almost entirely to moving at night, specifically to avoid running into people, and that they'd mapped the neighborhoods well enough to time their visits to trash collection days, showing up when the cans are full and out at the curb. The largest land animal in the state has quietly worked out the municipal calendar. The Florida black bear, Ursus americanus floridanus, is big. Males pass 250 kilograms, and in autumn it gets strange about food. Its metabolism flips into a state called hyperphagia, a kind of programmed binge to prepare for winter, even in Florida's mild version of one. In that mode, a bear can put away up to 20,000 calories in a day and spend as much as 20 hours straight doing nothing but eating. And it finds that food with a nose that's hard to believe. The smelling surface inside its snout covers an area roughly 100 times larger than a human's, and its sense of smell is estimated at several times sharper than a tracking bloodhound's. It can pick up the scent of food scraps sealed in a freezer in a closed garage from miles off, which is exactly why it ends up in the garage. Here's the part that doesn't fit the monster image. Around 80% of what a Florida black bear eats is plants, berries, and insects. It is not stalking people. It mostly wants fruit and bugs and whatever's in the trash. The danger isn't appetite, it's geometry. When something that size gets cornered between a fence and a garage and a person in a suburban lot, its defensive reaction is the problem, not its hunger. And running isn't an option because despite all that weight, a black bear can hit 50 kilometers an hour in a short sprint, fast enough to run down an Olympic sprinter without trying. So the most dangerous land animal in Florida is a near vegetarian with a perfect nose and a copy of the trash schedule that would honestly prefer you weren't there and can catch you if it decides otherwise. Florida panther. There's a sound people in rural South Florida hear at night sometimes, coming out of the cypress that stops them cold. A high, drawn-out scream that sounds almost exactly like a woman or a child crying out in terror. The first instinct is that someone's in trouble out in the dark. Nobody is. That's the Florida panther, and the scream is just the sound it makes because it physically cannot make the sound you'd expect. A lion or a tiger roars. The panther can't. The structure of a small bone in its throat is rigid, where a roaring cat's is flexible, and what comes out instead is that eerie, human-pitched cry. The most powerful predator in the state announces itself in a voice that sounds like a person screaming. The Florida panther, Puma concolor cori, is the same animal known elsewhere as the cougar or mountain lion, and it is critically endangered, somewhere around a couple hundred adults left, tucked into the shrinking cypress and pine forests of the South. As luxury development pushes deeper into what's left, you will almost certainly never see one. That's not luck. It's design. A panther can follow a deer, or a person, for kilometers through dense brush without snapping a single dry twig, moving in total silence, holding back, waiting. When it does commit, the strike is built to land on the back of the neck and break the spine before the prey registers anything is there, and it's built to cover ground in a way that makes its silence even worse. Its hind legs are proportionally larger and more powerful than the front, a skeletal arrangement that turns the whole animal into a spring. From a standstill, no running start, a panther can clear more than 12 meters horizontally and leap several meters straight up. Fences, gaps, the distance you'd assume was safe. None of it means what you think. And the territory it patrols is vast. A single panther's home range can cover up to 500 square kilometers, which means one cat passing near a property today might be quietly moving through the land behind dozens of neighboring farms over the following weeks, monitored by no one, seen by no one. Here's the honest part. The thing that keeps the panther in a different category than most of this list. There's no record of a Florida panther killing a person. The danger here is pure capability. The animal is equipped to do it and simply hasn't, because it wants nothing to do with people. And the proof of how thoroughly it avoids us is in how these animals actually die. Radio collar tracking has shown that the single leading cause of death for Florida panthers now isn't disease, isn't other panthers, isn't starvation. It's cars. They get hit on the interstates at night, crossing roads that were laid across their territory. The one apex predator that the swamp itself can't beat is being killed, more than any other way, by traffic. Nile crocodile. The panther could kill a person and doesn't. The next animal would, and it isn't even supposed to be here. 3 separate times now, Florida has pulled a crocodile out of the swamp that had no business being on this continent. Not an alligator. A Nile crocodile, the African one, confirmed by DNA testing at the University of Florida. And the genetics turned up something worse than "it's here." The captured animals were closely related to each other, and they traced back to one of the most aggressive lineages in Africa, and at least one of them had been living free in the Everglades for more than 2 years. Surviving and growing, this matters because of how it looks. To anyone but an expert, a Nile crocodile sitting on a bank looks like the native alligators Floridians have spent their whole lives learning to live around. Give it space, don't feed it, and it'll generally leave you alone. That assumption is the trap. The native alligator usually retreats when a person gets close. The Nile crocodile does the opposite. It's a known man-eater in its home range, responsible for hundreds of human deaths a year across Africa. And it actively studies the patterns of animals coming to the water's edge and plans ambushes, launching nearly its entire body out of the water to take prey on the bank. It has zero evolutionary history with humans that tells it to be careful. To a Nile crocodile, a person at the waterline is just prey that hasn't been caught yet, and it's wearing the exact disguise that makes Floridians let their guard down. The hardware backs up the behavior. A big Nile crocodile's bite force can exceed 5,000 pounds per square inch, more than double the native alligator's already brutal bite, enough to crush a skull in a single motion. And when it pulls something into the water, it has a piece of anatomy that makes the death roll possible. A fleshy valve at the back of its throat that seals the airway completely. With that valve shut, the crocodile can open its mouth fully underwater, lock on, and spin its entire body to tear the prey apart without swallowing a drop of water or drowning. It can dismantle something underwater while breathing room air the whole time. And the part nobody has a clean answer to is whether the 3 that got caught were the only ones. The same genetic work that confirmed the lineage also confirmed these animals were thriving in American swamps. And a creature that's that good at hiding, in terrain that already swallows 13-foot pythons whole, doesn't necessarily turn up on a road where someone can spot it. Scientists have been careful not to overstate it. But the possibility on the table is that Nile crocodiles are out there in the back country, away from the roads, quietly doing the one thing that would make this permanent: breeding. Red tide. That's the largest set of jaws in the swamp. The last thing on this list has no jaws at all, and it kills more than any of them. It's invisible, a single cell, far too small to see, and during a bloom, there are billions of them in a stretch of water, and they turn the Gulf the color of rust. This is Carenia brevis, the organism behind Florida's red tide, and calling it an animal is a stretch. It's a microscopic drifting cell, but what it does to the Florida coast outpaces everything with teeth. When these cells multiply into the billions, they stain whole sections of the ocean a dark reddish brown, and they start killing on a scale the predators can't touch. Tons of fish. Sea turtles, dolphins, manatees dead in a matter of days. In a bad bloom, the dead wash up by the truckload. The weapon is a toxin the cells produce, called brevetoxin, and it works by jamming open the sodium channels in nerve cells, locking them in the on position so the nervous system fires uncontrollably until it collapses. That's what's killing the marine life. And here's what makes red tide different from anything else in Florida. It doesn't stay in the water. When the waves break during a bloom, the cells rupture against the shore and release their toxins into the salt spray, and the wind carries that spray inland as a fine, invisible mist. The ocean turns itself into a toxic aerosol and breathes it onto the beach. During major blooms on the Gulf Coast, local hospitals report sharp spikes, well over 50% in some events, in emergency visits for severe breathing problems and asthma attacks, in people who did nothing but stand near the water and inhale, and it doesn't even need the air to reach you. The brevetoxins build up and linger in the tissue of filter-feeding shellfish, oysters, clams, the things that strain the water for a living. They concentrate the poison and hold on to it. Anyone who eats shellfish harvested from those waters during a bloom or in the weeks after one can come down with neurotoxic shellfish poisoning, temporary paralysis, reversal of hot and cold sensation, neurological symptoms that arrive hours after a meal that looked completely normal. The deadliest thing on this entire list isn't the alligator, or the crocodile that shouldn't be here, or the shark in the river, or the snake in the pine flatwoods. It's a single cell you will never see. It isn't really an animal at all. And in one bad season off the Florida coast, it has killed hundreds of manatees, dolphins by the dozen, a whale shark, and more fish than anyone could count. And not one of those deaths came from anything anyone could see coming.